Hi everyone, welcome to this channel zoologybio. In this series of video I am talking about the enzymes, the chemistry of enzymes. And in this video I am talking about the specificity of enzymes and the mechanism of enzymes. Now let's start with the specificity of enzymes. Specificity of enzymes. Another important property of enzymes is their specificity. The specificity is of three different types, namely, the first one is stereochemical specificity, the second one is reaction specificity, and the third one is substrate specificity. Optical specificity. There can be many optical isomers of a substrate. However, it is only one of the isomers which acts as a substrate for an enzyme action. For example, for the oxidation of D and L amino acids, there are two types of enzyme which will act on D and L isomers of amino acids. Secondly, there can be a product of enzymes action which can have isomers. However, it is only one kind of isomer which will be produced as a product. For example, succinic dehydrogenase, while acting on succinic acid, will give only fumaric acid and not malic acid, which is its isomer. And now the second one is reaction specificity. A substrate can undergo many reactions, but in a reaction specificity, one enzyme can catalyze only one of the various reactions. For example, oxaloacetic acid can undergo several reactions, but each reaction is catalyzed by its own separate enzyme, which catalyzes only that reaction and none of the others. The third one is substrate specificity. The extent of substrate specificity varies from enzyme to enzyme. There are two types of substrate specificity, that is absolute specificity and relative specificity. Absolute specificity is comparatively rare, such as urease, which catalyzes hydrolysis of urea. And the relative substrate specificity is further divided as group dependent or bond dependent. Examples of group specificity are trypsin, chymotrypsin. Trypsin hydrolyzes the residues only lysine and arginine, while chymotrypsin hydrolyzes residues of only aromatic amino acids. Now let's have a look to the mechanism of enzyme action. Michaelis and Menton have proposed a hypothesis for enzyme action, which is most acceptable. According to this hypothesis, the enzyme molecule, which denotes as E, first combines with substrate molecules, which denotes as S, to form an enzyme substrate, which denotes as ES complex, which further dissociates to form product, which denotes as P, and enzyme, which denotes as E. Back. Enzyme once dissociate from the complex is free to combine with another molecule of substrate and form product in a similar way. The ES complex is an intermediate or transient complex, and the bonds involved are weak non-covalent bonds, such as the hydrogen bonds, van der Waals forces, hydrophobic interactions. Sometimes two substrates can bind to an enzyme molecule, and such reactions are called as bisubstrate reactions. The site to which a substrate can bind to the enzyme molecule is extremely specific and is called as active site or catalytic site. Normally, the molecular size and shape of the substrate molecule is extremely small compared to that of an enzyme molecule. The active site is made up of several amino acid residues that come together as a result of foldings of secondary and tertiary structures of the enzyme. So, the active site possesses a complex three-dimensional form and shape, provides a predominantly nonpolar cleft or crevice to accept and bind to the substrate. Few groups of active site amino acids are bound to substrate, while the few groups bring about change in the substrate molecule. And that's all for today. If you like this video, hit the like button and share this video as much as possible. To get more videos related this topic, subscribe this channel. Thanks for watching this video.